Alright, so as you guys can see, while I am off in Phoenix doing Arizona things and learning about teacher stuff, you guys are going to be learning a little bit about scientific notation. So I know, like I said, we're going a little bit out of order for the 802 class in their OneNote notebooks. This is actually the last lesson in the unit, but I thought this would be the best one for a video. So we're going to learn about scientific notation in 802 class, and it's the last lesson in the unit. And then from 801, guys, you got your hard copy of your notes, and it'll go along well for you guys, too. So actually, 801 and 802 doing the same thing this week. You guys can talk about it. You guys can compare notes and can help each other out a little bit. Going to learn a little bit about scientific notation. You see my scientist guy there. This is the biggest reason we call this scientific notation, I think, is because you see some of the bigger and especially the smallest numbers around, actually, when you're doing science. When you start talking about the size of bacteria and cells and different things like that, you get to be some really small numbers. And so we needed a simpler way of showing really big and really small numbers, and that's where scientific notation comes in. So first thing we got to talk about is just the general form of scientific notation. It says a number is written in scientific notation if it has the form c times 10 to the n. So a couple things that you'll notice when you're looking at my scientific notation. First thing that you'll probably notice is that they're actually using x to show multiplication. This is about the one time where you're going to get away with that in this class, where we're actually going to use x to show multiplication. We could use parentheses as well, but typically you'll see some number times 10 to the n. The other thing that hopefully we see two variables. First variable that we see is c. That stands for some unknown number, just like we've talked about, but there's some restrictions on that are down below. And then you see another variable, n, that's the power of 10. So it's 10 to some power, and that power is going to change. But two variables, and there's going to be a number in there each time. Now notice some big things that you need to remember, and it's going to come back to you on this video today. So make sure that you're either underlining or highlighting or paying attention. But the big thing, that number c, that first number, it has to be somewhere in between 1 and 10. And the big idea is it has to be greater than or equal to 1. So it could be 1 or bigger, but it has to be less than 10. It's a single-digit number. It can't be 10 or more. So this number out in front has to be somewhere in between 1 and 10. Greater than or equal to 1, well, still less than 10. The other idea with n is n needs to be an integer. That can mean positive or negative, and you'll see both today. You're going to see positive numbers in the exponents, and you're going to see negative numbers in the exponents. But it has to be an integer. You're not going to have 10 to the 1.5 or something like that. It's always going to be either a whole number or its opposite. And obviously not going to have the power 0, because anything to the power 0 is 1, which we'll go into a little more down the road. But it's going to be an integer of some type. Now I said it's either going to be positive or negative, and you're going to see that with our examples here. If it's positive, you're going to be probably dealing with the bigger numbers that are greater than 1. So if you see 10 to the 4th, 10 to the 5th, 10 to the 6th, those are bigger numbers. Expect those things to be positive and expect those to be larger. If you see a negative n, that means we're going to be dealing with some smaller numbers. So let's dive in and see if we can kind of figure out how this scientific notation works. It says write the number in scientific notation, and I think the big thing that you need to see on this set of notes is it says numbers that are greater than 1 will have positive exponents because the decimal must move to the right. And that's kind of what I just told you, but now it's in writing. It's something that you could actually star or highlight. The goal when I look at this is I see the number 22,000, but I want it to get to that look where it says c times 10 to the n. And we said I need c to be somewhere in between 1 and 10. The idea with this is always going to have to do with the decimal. The decimal is the thing that's going to be moving in scientific notation. So when I look at 22,000, I want to find where would the decimal be right now, 22,000. If I were to put the decimal in here, it'd have to go at the end, right? I'd have 22,000, and I could even say 0.0. What I want to do is I want to change this number. And I don't need the 0 actually there, but I want to change this number so instead of 22,000, I have some number in between 1 and 10. And so what happens, I'm actually going to move this decimal as many places to the left as I need to get a number in between 1 and 10. So watch, if I move this decimal once, instead of 22,000, I would now have 2,200. Does everybody see what I'm talking about? If I move the decimal in here, now I would have 2,200 left. If I move over again, now out in front, I would only have 220. But again, that's still not less than 10. So I move it again. Now I'm down to 22. I've moved it 3 places, and I'm still down to 22, which is still a little bit more than 10. If I move it once more, if I put the decimal right here, I would now have 2.2 with 3 zeros. And that is somewhere in between 1 and 10, and that is what I want. That's going to be my C number, 2.2. So I've found 2 and 2/10. That's going to be the number C that's somewhere in between 1 and 10. But now I have to multiply this times 10 to some power, and this number has to be worth the same thing I had to begin with. 2.2 times 10 to some power has to be the same thing as 22,000. So what I'm going to do is I'm actually going to go back and I'm going to think, well, how many places did I move that decimal again? Well, let's see. If I went from 2.2, and you'll notice I'll even change the color here so you can see. I'm thinking, how many times did I have to move it back? Well, I'd move it once. I'd move it twice, I'd move it 3 times, I'd move it a total of 4 times. I'd want to move this decimal back 4 places. And if I want to move a decimal 4 places, the key is that I actually multiply by a power of 10 with 4 zeros. So I want to multiply this number by 10,000. Well, the shortcut there then is if I want to multiply with 4 decimal places and 4 zeros, that's going to end up being 10 to the 4th. However many decimal places you need to move is the power that you're going to use. However many decimal places you want to move it back is the power of 10 that you're going to use. So let me give you another example of a big number. This one's 1,317,000. So you're starting to see why we're dealing with big numbers when we're talking about scientific notation. Again, to get it to be c times 10 to the n, I need a number somewhere in between 1 and 10. So I play that, well, where's the decimal game again? And so I put the decimal at the end here, and I think, all right, how many times do I need to move it to get to a number less than 10? If I move it here, I'm still quite a bit bigger. If I move it here, I think we can all see I'm still quite a bit bigger. Even here, I'm at 1,317, so that's not going to work. I move it again. Now I'm at 131. I move it again, and I'm right here to 13. Not quite where I need to be. This would be 13.7. And so I move it once more, and now I found a number somewhere in between 1 and 10. And when I look at this C value, I have 1.317 and then 3 zeros. I know I don't need those zeros at the end, but I can't get rid of 317. So this C number is actually going to be 1.317, or 1 in 317 thousandths. That's the C number. Again, I'm going to take it times 10 to some power that will get me back to where I started. So what I want to redo is I want to retrace my steps and think, okay, if I had the decimal here, but I want it back to where I was to begin with, how many places would I need to move that? So I count 1, 2, 3, 4, 5, 6. It looks like we moved it a total of 6 places. And because I want to move it back to the right, I want a bigger number. It's going to be a positive 6. If I took 1.317 times 10 to the 6th, which, by the way, 10 to the 6th, that's going to have 1 and then 6 zeros. That's a million there. I'm going to say 1.317 times 10 to the 6th is my answer in scientific notation. So again, that's numbers that are greater than 1. They'll have positive exponents. These are bigger numbers. Remember, scientific notation also deals with smaller numbers. So we'll see how that changes things. If I want these numbers in scientific notation, these are numbers less than 1 to begin with. They're very small. These are going to have negative exponents. So now when you see here, numbers less than 1 are going to have negative exponents because eventually the decimal is actually going to move to the left. And so this is a little trick about negative exponents that you're going to learn down the road. But negative exponents really have a lot to do with these smaller numbers. So the game goes the same. I look at this number and I actually have 45 10,000ths. I want this to be C times 10 to the n. Some number in between 1 and 10 times 10 to some power. So now instead, notice back here, we actually moved the decimal to the left initially and then we're able to move it back to the right. Here it's the opposite. I need this number to be in between 1 and 10, so I'm going to actually make it bigger. I'm going to move this decimal once, twice, 3 times, so I now have a number that's in between 1 and 10. And hopefully you see that if I move this decimal 3 times to the right, I would have the number 4.5, or 4 and 5 tenths. So I have 4.5 as my C number. Now I need to take that times 10 to some power. Here's the trick now, and I want you to notice, instead of moving this decimal to 3 places to the right, I need to move this thing 3 places to the left. I need 4.5 to actually get smaller. And so for 4.5 to get smaller, I can't do 4.5 times 10 to the third. That's like multiplying 4.5 times 1,000, and that obviously gets bigger. To make it smaller, I need to take 4.5 times 10 to the negative third. Any of these times where we have smaller numbers, numbers less than 1, it's going to be the same process, but your power of 10, your n value, is actually going to end up being negative. So another example where we look at this, very, very small number here, 0.000007. So obviously something where we're talking about a very small number, not something we'd even read very naturally. We're going to use scientific notation to write this number now. So again, I start with my decimal and I need to move it until I have a C value in between 1 and 10. So I go once, twice, 3 times, 4 times, 5 times. Sometimes you guys might be tempted to stop here, but notice this is 0.7. That's still not greater than or equal to 1. So I have to move it once more, and now I actually have the number 7. So think about this now. I'm going to take 7 times 10 to some power. And again, I ask myself, well, how many decimal places do I need it to go back to the left? Well, I need it to go once, twice, 3 times, 4 times, 5 times, all the way back 6 times. So 7 times 10 to the what? Since it's smaller, it's going to be to the negative 6th, since I wanted to move it to the left. That's not all I'm going to have you do with scientific notation. Obviously here, I'm giving you a number in what we would call standard form, and you're writing it in scientific notation. I give you a number that you're used to. and you write it using the c times 10 to the n pattern. The other thing that I'd expect you to be able to do is if I give you a number in scientific notation, you should be able to write it in standard form. So this goes back the other way. Basically what I'm looking at in this situation, I have 4.2 times 10 to the 6th. So I start with my c value of 4.2, and then I think if I multiply times 10 to the 6th, based on what we just talked about back here, that means we're going to move the decimal 6 places to the right. And so that's exactly what I'm going to do here. I'm going to actually just take this decimal and I'm going to move it 6 places to the right. So you can count with me: 1, 2, 3, 4, 5, 6. And notice I'm trying to be very precise on how I do this because it's really important that I can write this number correctly. Each of these spaces, since we have moved the decimal, they're going to need a number to fill in there. And so if there wasn't anything there to begin with, that's where I'm going to be putting in zeros. Each of these spots will become a 0. And now I'm not done. I need to write this number in standard form. That means cleaned up with commas where they belong and everything else. So I look at this, and if you don't remember where your commas go, I can start at the right. I'll start over here at the right. Every 3 places to the left, I'll put in a comma. So I count 1, 2, 3, and then I'm going to put a comma. And then I count 1, 2, 3 again, and I'm going to put one more comma. And so you notice 4.2 times 10 to the 6th actually becomes 4,200,000. And this is what I would expect your answer to be. You can do all that work moving your decimal and filling in your zeros and everything else. Then make sure you come down and just write a nice, neat answer in standard form. Remember, it doesn't just work with the big numbers, it also works with the very small numbers. Very similar pattern here. I'm going to start with my c value of 1.15, or 1 in 1500ths. Notice this is times 10 to the negative 5th. So what changes for me here is I'm going to move the decimal 5 places, but it doesn't make sense to move it 5 places to the right. This number is small. This number's got to get smaller. So I'm actually going to move this decimal 5 places to the left. So watch very carefully as I move this 1, and I've moved it once. Hopefully some of you guys can get this figured out. It's a negative 5. I've moved it once. Hopefully you can predict how many zeros we're going to end up with here. But I move it once, twice, 3, 4, 5. Really important that I keep track of the decimal right here now. That's where my decimal is at. Again, just like we talked about before, we're going to come in and fill in these blanks with zeros. So if I count my blanks here, I have 1, 2, 3, 4 blanks. Hopefully you figured that out. Move it once, then the rest would still be zeros. So I have 1, 2, 3, 4 zeros. Then I have my decimal. Don't forget, if I have a decimal number like this, I need a 0 out in front as well. So now I can come down here and write my answer in standard form. I see 0 point, and then I have 4 zeros, and then I have 1, 1, 5. And you can see why that's a very small number and where scientific notation might be helpful. Last thing really tricky for you guys is doing some calculations, doing some computations in standard form. This is definitely the stuff to maybe rewind and pause and ask questions if you need to. But there is a little trick where we can actually multiply and divide using standard form. I'm not going to have you do the division while I am gone this week, so any of those division problems on your assignment you can skip. But I will ask you to find some products. I will ask you to do some multiplication. So I'm going to give you some numbers in scientific notation, and you're going to actually have to find the answer using scientific notation. Not by getting them into big, messy numbers, but just do the problem and write your answer in scientific notation. So a couple things that I want you to notice. We are going to use scientific notation to find the product, and product means to multiply, and then all the tricks that you need are right over here. It says we're going to multiply the coefficients, and we're going to add the exponents, and then we're going to write our answer in scientific notation. So let me show you what I mean here. This says 1.5 times 10 to the negative 4th, and we're going to take that times 5 times 10 to the negative 6th. So we're multiplying these two things. Now one thing that I want you to notice, the first number times 10 to the negative 4th, that's a pretty small number, whereas the second number times 10 to the 6th, that's a little bigger number. So it'll be interesting to see how this works out for our answer, what type of number we get in between. But it says multiply the coefficients. When I talk about the coefficients, and this might be something to add to your notes, but when I'm talking about the coefficients, I'm talking about the C term. I'm talking about that number out in front. You're going to multiply those two numbers out in front. So I'm going to take 1.5 and I'm going to take it times 5. So just like you would normally do. I'm going to come down here and I'm going to multiply the C values. And I have 5 times 5, which is 25. I carry the 2. 1 times 5 is 5 plus 2 more is 7. I have one decimal place factor up here, so I'm going to say, all right, I have 7.5. So I've got my answer started. It's going to be 7.5 times 10 to something. I just multiplied my C values. And that's all you're going to do each time. The second thing it says to do is add the exponents. Well, your exponents are really your n value, or your n term. So now I'm going to look at my two exponents and I'm going to add those together. So in the first term I see I have a negative 4, and in the second term I see I have a positive 6. So I'm going to say, all right, I'm going to take negative 4 plus 6. And you might remember from your background knowledge, I asked myself, well, are they coming together? Are they battling? Who's going to win and by how much? And I notice if I take a negative 4 plus 6, I'm going to get 2. And so my final answer here, if I look back over here, I have 7.5 as my C value times 10 to what power? Well, it turns out to be to the second power, which means this is actually a pretty small number now. It's only 750 if you actually wrote this in standard form. But that's my answer in scientific notation. Again, multiply the C values, add the N values. Multiply the coefficients, add the exponents. Last example, I would like you to star this one. This one is a little tricky. This is the one that gets you on quizzes and on assignments, and I think you'll see what I mean. We're going to write our answer in scientific notation. You guys all might think I'm crazy for thinking this is a hard problem. Remember, the first thing we're going to do is multiply our C values, and I take 2 times 6. All right, well, 2 times 6 is 12. Everybody thinks we're okay there, so I got 12 times 10 to some power. And then I look at my N values, or my exponents, and I say, well, all right, I got 3 plus 6. 3 plus 6 is 9. All right, I got 12 times 10 to the 9th. Hey, Mr. Bartlett, I'm done. Hopefully someone in the room right now is thinking, well, 12 times 10 to the 9th, that's not written in scientific notation. If you remember back at the very beginning of the video and the very beginning of your notes, C, the C value, the number out in front, has to be somewhere in between 1 and 10. It can be equal to 1 or greater than 1, but it has to be less than 10. It cannot be 2 digits. And so when I look at this number, 12 times 10 to the 9th, well, 12 is too big. And so this is the hardest thing for kids to figure out. I want you to watch very carefully, but I have to make 12 a smaller number. So I want to think about this. This is almost what I'm doing on any other time. I'm going to say, well, where is 12's decimal right now? And it's right after the 12. And I have to move it. And so 12 is in between 1 and 10. And so I think everybody sees, well, okay, I'd move it once over to the left, and I'd make this 1.2. And that's absolutely correct. That's going to be our C value. The tricky part now becomes, what does our N value have to be? What I want to do, and what you're going to have to do repeatedly, and you're going to have to talk this through a little bit, is I want to check, well, what does this N value mean now, and how does my movement of this decimal right here affect that N value? So remember, if I look at a 10 to the 9th, that means we're going to move the decimal 9 places to the right. If I wanted to make 12 times 10 to the 9th into a standard form number, I'm going to move this decimal right here 9 places to the right. Well, so now what happens if I've already moved it 1 place to the left and it's now in between in the 1 and the 2, I still need to move it to the right. I need to move it the original 9 spots that I would have already had to move it, but I also need to move it that 1 extra spot since I moved it to the left. And so instead of 12 times 10 to the 9th, this becomes 1.2 times 10 to the 10th. And that is not necessarily always going to be the case. It's going to matter when you're moving the decimal to the left or when you're moving the decimal to the right. And if you changed your C value and made it bigger, or if you change your C value and make it smaller. These are definitely the hardest problems. Not so much when it works out nice and neat in scientific notation like the first example, but on this second example, you're definitely going to have to do a little reasoning to make sure your C value is somewhere in between 1 and 10, and make sure your N value corresponds to what it should to get you the correct answer in standard form. So again, a little bit of scientific notation, just remembering that it's C times 10 to the N, where 1 is less than or equal to C, which is less than 10. This hopefully gives you a really good background on what you need to do for the next couple days. Obviously, you'll have your teacher to help you, and you'll have each other to help you. If you have any questions, I'll answer them when I get back. Otherwise, the best of luck to you guys.